Hi everyone, it's Coach Fred here, and today I'm going to be talking about functions and relations and domain and range. All right, so these are just some vocabulary words we want to make sure we know so that we can use them. But a relation or a relationship, a relation in math is a set of pairs of inputs and output values. So, and we can write relations as ordered pairs. Now remember, an ordered pair is like a coordinate point, and it comes in the form with an x and a y. But we need to define which one of these, which each variable means. And so we call x our independent variable. So our independent variable is the x, okay? Those represent the inputs of a function. Now it doesn't always have to be x, but it does have to be the input. And the dependent variable is what comes out when you plug in that input. And we've been spending time doing that by making tables of values. So our dependent variable is y, and it's our outputs. Now, we have been talking about how sometimes we look at things symbolically, graphically, and I want you to actually ask yourself, if you're unsure, I always want you to ask yourself in a real life example, what depends on what? Why do I ask myself that question? Well, that question can help me decide what the independent or the dependent variable is, because y always depends on x. Now, if I go back to the example that we did yesterday in class with the plumber, then we were dealing with the total cost the plumber charged and the number of hours he worked. So if I think about that and I ask myself, well, what depended on what? Does the cost depend on the number of hours he works, or does the number of hours he work depend on the cost? Well, hopefully you're saying to yourself that the cost depended or depends on the number of hours he worked. And that was why the number of hours he worked was our x, okay? All right, so now let's take that one step further. When we're dealing with functions and relations, these x and y's represent something called the domain and range of a function. The domain of a relation is the set of all inputs or x coordinates of the ordered pairs. The range of a relation is the set of all outputs or y coordinates of the ordered pairs. Now we're going to be looking and diving deep into domain and range in a little bit. All right, but let's spend more time talking about what a function is, okay? So a function is a relation in which each element of the domain is paired with exactly one element in the range. Okay, so that's the mathy definition. What I like to say, get you to understand, is that for every x, there is only one unique y. There is one unique y. That means that you can't have repeated x's if something's going to be a function. When I think of a function, I actually like to think of a vending machine. So I'm going to take a second and talk about that. So here I have this vending machine. I'm going to draw it. Coach Fred's drawing a bad vending machine. And I've got, Doritos and Fritos and chips and a Kind bar and a granola bar and a chocolate bar. And each one of these, we're going to give a number, like a number. We could say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. I'm actually going to add Funyuns on this list, okay? All right. So if I press 2, I'm going to say the input, then out should come Fritos, right? Those Fritos. If I press 3, then chips should come out. That would make it a function. If each one of these numbers, I could only get one result, then it would be a function. But if I press 2 and I could get Fritos or Funyuns. If I pressed 2 and I wanted the Fritos and the Funyuns came out, I'd be mad. I would kick the machine. I would say it's broken. And that's because it would not be a function. Because for one input, for one X, I could get 2 different Ys. So those would not be a unique Y. And that's a function. That's what makes something not a function. Sorry. All right, let's go back to that. So what should you look for if you're trying to determine if something is a function? Well, there's lots of ways to do it. If I'm given just a relationship, so a list of coordinate points or ordered pairs, I want to look for the same X value but different Y values. If you get that, it means it's not a function. Then I'm going to show you how to state the domain and the range. All right, so here's a set in A. Here's a set of relations. So I look very carefully to determine if it's a function. I look for any repeated X's. I don't have any repeated X's, so yes, it is a function. Now the domain. The domain is the X coordinates of this relation. The range would be my Y coordinates. Now I'm going to use set notation or to list this. So we're going to use a bracket. And all we do is we list our X's and in order from least to greatest. So my domain would be -3, 2, 5, and 8. And again, I'm going to use brackets. Not too bad, right? The range would be the Y values. So in this case, I'd have -7, 1, and 5. Now I only have to list that one once. Now you might say, but Coach Fred, 5 has 1 and 8 has 1. It's okay to have repeated Y's. We just can't have repeated X's with different Y's. So that's where we have to be really clear. All right, let's look at the next one. Here we've got this relation. So what do? I look for repeated X's. So I have 3, 1 and 3, 3. So they have different Y's. So this is not a function. No. That doesn't mean it doesn't have a domain and a range. It does have inputs and outputs. It's just those outputs are not providing me with something that's a real function. All right, so my domain, again, is my X coordinates. So what do we have in order? I'd have -2, 1, and 3. And my range would be, 0, 1, 3, and 4. Again, look for repeated X's. If they have different Y's, then it would not be a function. All right, so let's move on a little bit. That's one way that I can give you relations is just to list them in ordered pairs. Another way I could give you a relation would be in something called a mapping. A mapping would look something like this, with inputs and outputs listed. Sometimes the mapping is going to have the data points in an oval. And so for each of the inputs or X's here, the arrow is pointing to the output it gives you. Now, if this is unclear for you, you can still write them as ordered pairs. So for example, -3, 3 would be the ordered pair from this mapping. 1, -2, 1, 1, and 4, 4. Now you don't have to do that. Some of you might just see it clearly. But now I can see very clearly that I have repeated X's here that have different Y's. They have different Y's, so this is not a function. The domain, however, would still relate. That's my inputs. So my inputs would be -3, 1, and 4. And my outputs would be, -2, 1, 3, and 4. All right, now let's look at this next mapping. Looking at this, I have -3, 3. I have 1, 1. I have 3, 1. And I have 4, -2, those same points. Now, I have no repeated X's. I do have repeated Y's, but that's okay. No repeated X's, it's a function, yes. So I'd like you to go ahead and list your domain and your range, okay? All right, moving on, I want to talk about 2 very special equations, okay? These are linear equations, but they're special ones. Do you remember which ones they are? Take a minute and think about it. Okay. We've talked about the fact that there's 2 very special lines. When we have one variable equations and I want to graph them, well, if we have y equals a number, this represents a constant function or a horizontal line. And If I have only an x coordinate, so x equals some number, then this represents a vertical line. We've talked about how we can get inputs and outputs on these. But if I think about the points on a horizontal line going through 5, I'm going to do that for a second. I'm going to go to y equals 5. So 1, 2, 3, 4, and 5. I'm going to draw a horizontal line through it. If I asked you to pick ordered pairs that are on that line, there's an infinite number of ordered pairs. So let's pick a couple. Let's see what happens. Okay, if I made a table, I'm going to make a table going this way. So for an x of 1, I have 5. For an x of 2, I have 5. For an x of 3, I have 5. For an x of 4, I have 5, and so on. So in this table of values, you can see that the ordered pairs, I have no repeated x's, while I do have repeated y's. So by looking at it, a horizontal line, yes, it is a function. The domain is all of the numbers in the real number line set. So every single number, we would say that's called all real numbers. Whereas the range is the y values. This only has 1, so the range here would be 5. Now a vertical line, let's look at a vertical line. So I'm going to do that same thing. I'm going to go create a coordinate plane with my x and my y's. I'm going to go to 2. I'm going to draw a vertical line. I'm going to use purple. There's my vertical line. Now if I were to create a table of values for this, let's see. 1, 2, oops, I can't use that. 1, 2, 3, 4, 1, 2, 3, 4. If I picked, I don't know, -2 right here. If I picked x of 2, if I picked x of 2 right here, x at 2 would give me -2. X at 2 could give me -3 right here, -4. So hopefully you're noticing that I've got all these repeated x's that have different y's. So a vertical line is not a function. Why? Because it has all kinds of it's got an infinite number of repeated x's with different y's. So it is not a function. And this is going to be really helpful when we look at graphs, because I can use this vertical line to quickly tell if graphs are functions. Okay. I'm going to stop right here because what we're going to be doing next is we're going to be looking at how we can tell if other equations are functions, okay? So I want you to take a second and answer the questions on the Ed Puzzle, and we will meet back up tomorrow. Have a great day.